Okay, just recently I had computed 5p3 was 60. Now I did not try to list 60 ordered triples. However, what if we were to pick from these three things, but order did not matter? I claim that there are 10 ways that we could pick a triple where order does not matter. And then we'll talk about the connection between this versus this. I could pick A, B, and C. Notice that I'm putting the curlicue braces there because order does not matter. The parentheses would be suggesting an ordered triple. This is an unordered triple. I could choose A, B, and D, or A, B, and E. I'm pretty sure those are the only ways I could have both A and B in there. Let's see here. How about A, C, and D, A, C, and E. Then let's go with B, C, and D, B, C, and E, C, D, and E. So far, I have 8. Give me a moment here. I need to think. Pause this. Okay. Sometimes it's easier to keep track. Instead of from the 5 picking the 3, you could think of which 2 have been left out. So here I left out D and E. Here I left out C and E, C and D, B and E, B and D, A and E, A and D, A and B. So when I look at this, I see these 4 are all the ways I could leave out E and somebody else. I should be able to similarly come up with 4 ways to leave out D and someone else. Here's one of them. Here's another, a third, and a fourth. So now let's see how many ways I've left out C. Here's 1, 2, and looks like that's it. So what I've missed leaving out was both AC and BC. Continuing, B then should show up in 4 places. Here, 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 and now here. And A should show up in 4 places. Here, 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 and here. All right, so leave out AC. That's going to give me B, D, and E, which, double checking here, was not anything I had already listed. B, D, this has B, D, but A, not E. Remember, order does not matter. Okay, and then leave out BC. That should be my 10 ways that I could pick from 5 available, pick 3, no repetition, but order does not matter. Furthermore, I'm not going to write all of these, but if I were to take that unordered triple ABC, and put them into order, we're going to get 6 ways that one can be put in order. Start off with A, and then reverse whether B or C, whereas C follows, C follows B, or B follows C. Or start off with B, and then reverse the last 2. Or start off with C, and then reverse the last 2. For all of these 10, I could come up with 6 ordered triples, which is 3 factorial. So there were 10 unordered triples, but if I multiplied by 6 to find out how many ways to put them in order, I would get that 60. What I'm getting at is that this is talking about 53 things, talking about a combination. In a combination, there is no repetition, but order does not matter. With a permutation, there was no repetition. So that applies to both. But with a permutation, order mattered. With a combination, there's no order. Okay, so what we have just found out then is that the number of combinations in some textbooks as CNR, or in others NCR, which is the way it shows up on the calculator. We have found out that 5C3 is 10, and there's a formula involving the factorials. The one I prefer is to find out how many permutations there are and then divide by R factorial. If I went from that 60, divide by this, that's dividing out the ordering of the triples to get 10 unordered triples. As a matter of fact, if I had not done this earlier and I had to compute this by hand, well, cancel out the 3's. 2 goes into 4 twice, and dividing by 1 doesn't matter. So 5 times 2 is 10. And let's confirm that on the calculator. So type your value for N first, and then math and the probability submenu. This one is our third option, and we had to pick without repetition or order 3 things. There's 10. Now also notice this. Now earlier we had both seen from 4 things, picking and arranging 2 of them, that there are 12 ordered pairs we could come up with, comparing that to a special case of the multiplication principle. We also came up with 12. So what I am suggesting with NCR equaling NPR divided by R factorial, I'll pretend I didn't do this here, then for C2, when there are 4 things available and you want to pick 2 without arrangement, how many combinations are there? We have 4 times 3 over 2 factorial, so 2 times 1. Do some reducing there. 2 times 3 is 6. Well, try to back that up. When order does not matter, those two are the same. AC and CA are the same. AD and DA are the same when there is no order. BC and CB, BD and DB, same. And then CD and DC. Again, notice the use of the parentheses for the ordered pairs versus the curly Q braces for the unordered pairs. Okay, so checking 4C2 on the calculator here real quick. Let's see if we're getting 6 that way as well. Gotta wake it up. 4C2. There we go. All right. Well, let's build on that. In how many ways can an investor select 3 mutual funds for her investment portfolio from a recommended list of 10 mutual funds? You're not arranging those 3. You're just picking those 3 out of the 10. So we're looking for 10C3. By hand, $10C3 would be equal to 10P3 divided by 3 factorial. 3 blanks top and bottom. Up here, starting with 10, down to 9, down to 8. And by the way, a reminder, 10 minus 3 is 7. 7 plus 1 is 8. In the denominator, 3 factorial. 3 times 2 times 1. I'm going to do some reducing. Having that 1 in there is not going to change anything. 3 into 9, 3 times. And it doesn't really matter which even number I use the 2 with. So I'm going to go for getting a smaller number. 8 times 3 is 24. 24 times 5 is 120. Let's check out whether the TI-84 agrees that 10C3 is 120. So here we go. 10C3, wake up. Okay, 10C3, 120. It's all good. Continuing a little bit further. Let's say we have 10 seniors and 5 juniors in a business club at a high school. How many ways can you pick 2 seniors and 3 juniors to be going to a conference in Denver? Well, it's like we're building a committee to go to this conference. Committee combination. There's no ordering of who is attending that conference. What we need to do is pick from our 10 seniors, pick 2 of them, and from our 5 juniors, pick 3 of them. So I'm starting off first with an application of the multiplication principle. 10 seniors, we're going to choose 2, and 5 juniors, choose 3. 10, 2, 5, 3. This is picking the seniors. That's one overall task. And this is from the 5 juniors, picking 3 of them. Again, no repetition, no order. So by hand, I would have 10P2, which is just going to have 2 dashes. Divide out the ordering by 2 factorial. Here I'll have 3 dashes. Divide out the ordering of 3 times 2 times 1. Start with 5 here. Some reducing. Well, 2 into 10 5 times. Cancel the 3s. 2 into 4 twice. So I've got 5 times 9 is 45 times 10. Coming up with 450. This is the main thing, to recognize how many ways could we choose without repetition and without order. From the 10 seniors, pick 2 of them. From the 5 juniors, pick 3 of them. And then we're getting into the nitty-gritty of the arithmetic after that. Let's see if the calculator agrees on this one. Ten C2, 10C2. Come on. Times 5C3. Don't know if this is going to work, but 450. That's what I came up with. I'll say we take that a little further. Either we have the 2 seniors from the 10 and the 3 juniors from the 5, or 1 senior and 4 juniors. Well, the or should be telling us to add. Choose 1 senior and 4 juniors. By the way, why do I know I can add? That goes back to the fact that you have disjoint subsets or disjoint events. You cannot, for that one conference at that one time, both pick 2 seniors and 3 juniors, and at the same time, 1 senior and 4 juniors. Okay, so we're going to be adding to that 450. Well, there's only 1 blank, and dividing by 1 factorial is kind of boring. Here we're going to have 4 blanks. Divide by 4 factorial. Starting off with 5 up in the numerator. The 4 3 2s can cancel. 5 divided by 1 is 5. So 10 times 5, I'm coming up with 50. Total of 500 then. The biggest thing there, if you understood the previous example, was the or was telling us we're doing something very similar over here, and then we're adding them up. So let's see if indeed we take that previous answer and we add to that. Let's see here, previous answer plus, now it was 10C1. From 10, choose 1, no repetition and no order, and so multiply. From 5, choose 4 with no repetition and no order. And it works.